Hello everyone, welcome to today's session. Here we'll be solving problems on highway drainage system. The maximum quantity of water expected in one of open longitudinal drains on clay soil is zero point 0.9 meter cube per second. Design the cross section and longitudinal slope of trapezoidal drain, assuming the bottom width of trapezoidal section to be 1 meter and cross slope to be 1 vertical to 1.5 horizontal. The allowable velocity of flow in the drain is 1.2 meter per second and Manning's roughness coefficient is 0.02. So here if you see in the given question, they have given us the maximum quantity of water Q, zero point 0.9 meter cube per second, and they are asking us to design the cross section and longitudinal slope, and the shape also they have mentioned, that is trapezoidal drain with a base width 1 meter and a cross slope of the side drain they have mentioned 1 is to 1.5, and they have given Manning's coefficient of 0.02 and allowable velocity also they have given capital V 1.2 meter per second. So first of all we need to find the cross section. Here in the given question they have given us the velocity and quantity Q 0.9 meter per second as mentioned earlier. So you can find the cross sectional area of drain as Q by V 0.9 divided by velocity of 1.2. So we get the area as 0.75 meter square. They have given us that is a trapezoidal section 1 meter as the base width, right? So and the cross slopes also they have mentioned 1 vertical to 1.5 horizontal, right? So here I also had drawn the diagram. So it is total top width will be 1 plus this 1.5d this side, 1.5d 5d that side, so it is 1 plus 3d. So cross section area of the drain is equal to 1 plus 3d divided by into d divided by 2. That is why those many things. So if you see the cross sectional area, so here base and side widths, that is d plus 3d square by 2, which is equal to 0.75 because that is the area which you have calculated. So if you solve, that is 1.5 d square plus d minus 0.75 is equal to 0, and by solving the equation we are getting the d value as 0.45 meter, and allowing the freeboard of 0.15 meter, that is extra space, that is next the total depth of side drain is equal to 0.45 plus 0.15 is 0.6 meter. Next we need to find the slope. He has told us to use the Manning's formula. V is equal to 1 by n r is to 2 by 3 s square root of s. A roughness coefficient n for clay he has given as 0.02. Velocity he has mentioned 1.2 meter per second. We have calculated the wetted area of cross section, that is 0.75 meter square. Next we need to calculate the wetted perimeter. So that comes around 2.62 meters. Next, hydraulic radius R, that is nothing but area by perimeter, 0.75 divided by 2.62. So we got the value of 0.286. We know the value of V, we know the value of N, we know the value of R. What we need to calculate? We need to calculate the S. So just try. Put the values in this equation. Square root of S is equal to Vn divided by R raised to 2 by 3. So V is 1.2, N is 0.02, R is 0.286 raised to 2 by 3. So we are getting the value of S is equal to 0.0031 or 1 in 322.5. For field execution purpose, that may be taken as 1 in 320. So I'll quickly repeat what we have done, what we had given. With the given velocity and quantity, we have calculated area. Next, he has given us the shape. With respect to shape, we have calculated the cross drainage area of the drain. With respect to cross section area of the drain, we know the area. Equating with the equation, we got the value of D. Next, we are allowed some freeboard of 0.15. Total depth we have calculated. Next, we need to find the slope, longitudinal slope. He has given us the velocity and n value, reference coefficient for clay is 0.02. So using the as we know the weighted area of 0.75 meter square, weighted perimeter we have calculated, and we have calculated the hydraulic radius R, area weighted perimeter. Next, slope we calculated. So that's what he has asked. So area and the longitudinal slope. That is. Thank you very much.